nowhere. Are you sweating? All right, friends. We have some math to do. We're probably going to slow it down a scotch because we already slowed it down a scotch. Oh, sweet. Are you copying items? Where did you find those? You just figured it out from there. Nice. So if you want to, I talked to Miss Pegger, you don't have to, but you might confuse yourself a tiny bit. 1, 2, 3 is actually what's our assignment for today. So if your plan book still says 1, 2, 4, I don't want you guys to freak out about that. You can just change it to a 3 if you want. You don't have to though. As long as you can remember, I pushed things and extended things. But you have 1, 2, 3. So on your desk you should have out 1, 2, 2 and 1, 2, 3. And always and what's GP? Graph paper. Always graph paper. Addie, what's the question? I didn't say that yet, but you are correct. Would you like to say that louder so your whole class knows what you just said? Hey, those of you talking and not respecting the fact that Addie's talking are just going to miss what she says, so whatever. Just say it, and if they miss it, they miss it. It is open notes and open homework. I'm going to give you back everything. If you've turned in other stuff 1, 2, 1, I didn't get graded. I will get you that back tomorrow. I might have to miss game night tonight. But before we dive into, or actually we'll come back to this after we check our homework. So 1, 2, 2. Guys, a lot of you came to ask me for help on 70. And here's another one of those weird phoenixy things. I started saying skip it. And people would just look at me weird. I said, I know we should do this in class, so just wait. So if I told you skip this, now is when you need to do it. So I should see everybody with 1, 2, 2 out. It's easy to spot because it's got the bag on it. Anyone need 1, 2, 2? You were absent, something happened, you don't have it, Jaren. Question, different question, Alex?
Can I solve it?
Give me a sec. Everyone do it. Everyone have 1, 2, 2.
Yeah.
1, 2, 2 in front of us, looking at the front. Okay, so what's the first thing, Alex, that we want to do in this situation that tells us about all of these marbles?
We have to divide.
Not the first thing. We'll get there, right? You're just too far into the problem. Jana? Yeah, no, this is where it gets weird. Because they tell us there are 10 marbles in the bag.
Yeah.
But then they tell us this. What is this? What? Because it's way more than 10. Donovan?
He has recorded his random picking out of the bag.
It's the experiment, right? We talked about experimental probability. They did the experiment. How many times did they do the experiment? 50. So the first thing that you want to do is realize they did this 50 times. That does not mean there are 50 marbles. That means they did the experiment 50 times. Remember our spinner from yesterday and 2 days ago that we spun 10 times or 20 times? And the experimental isn't always the same. So Alex, you said we got to divide. Can you talk me through what we do for purple?
So purple, we have 9, so we divide 9 by 50.
So we set up 9 over 50 because we had 9 purples
Times 100.
out of 50 total. If this is not done on your paper, I should see you doing it right now. If this is not done on your paper, I should see you doing it right now. Thank you for helping. I can make sure you're helping yourself. You got to get this copy too. That's 1, 1, 2, and that's already graded. So 1, 2, 2. I'm wondering if this is there you go. On this front problem. And guys, if you are like me, highlighting the 9 purple or the 50, whatever, highlighting would help. So then, Alex, why did you say we divide?
Because once we divide 9 divided by 50 times 100, they equal 18%.
Ooh, so that is a method that you could take. So Alex is going to take the percent method. Alex figured out it's 18%, but then you're going to have to round, right? Like, I'm still talking to you, Alex.
Yeah.
So I took a different method. Could Alex and I still get the same answer?
Yeah.
Yeah, different ways to get to Florida. Have we talked about that in here? Or do you just think I'm weird?
No, but
Okay, if we're going to Disney, you can take your route, I'll take my route. We're gonna meet at the one with the monster up the mountain. What's the ride with the Yeah, but what's never mind. I'll think of it in like 10 minutes. So I rounded right here. Right? I rounded here. It said 10 is a much nicer number. But you can wait to round till the end of the problem if you want. So that's the route Alex took. If it was 10 out of 50 and we reduce it to get a denominator of 10, how did I do this? Dave? Divide by 5. Which Lacey tells me I also have to. Sorry, Lindy. I owe you a piece of candy. I taught Lindy's sister Lacey, and that I like swore I would never do that where I accidentally call a kid their sibling's name. I owe you candy. Okay. Congratulations, I'm getting old. So Lindy gets free candy, didn't even have to answer it. It means we have to do it on top also.
Yeah.
Questions. I'm just stretching around. Addie?
Don't feel bad that you called Lindy Lacey. My music teacher my art teacher,
Yeah.
She was like 20, called me Kevin, which is my dad's name.
Oh wait, how did that young art teacher know your dad?
Parent teacher told me this. Also, we look alike.
What why would she have called you your dad's name? Okay, if you guys look alike, that makes sense. So similarly, orange. If you don't have this done, you should be doing it. Orange. 16's not very nice though. 16 can't divide by 5. Well, it can, but not nicely. So we round it to 15, and we do it that way. So about, right? Our answers are like approximates. Are you getting this now?
Yep.
Because I revealed more. Yeah, Alex?
Can I explain the process?
I mean, again, sure.
Can I teach?
I mean, if you can do it in under 2 minutes.
Okay.
I mean, are you going to show your percent method or what?
Yeah.
Let's...
I'm gonna finish it because the rest you did it in the way that you did it.
So you chose to sit there. So I'm gonna write it up here to make sure that like we can read it all. So for like yellow, let's walk through yellow, which I got smart and I didn't write in yellow because that would be hard to see. So talk me through yellow, Alex.
So for yellow, you would start out with 6, and then what you do is you divide the number by 50, and then multiply
So you got 0.12, right?
I got 1.2, and then I rounded up, so that was hold on.
I see what. Yeah, I'm with you.
So
I do know what you did.
What I did is 6 divided by 50 times 10 equals 12%, and then 12% divided by 10 equals 1.2, which rounds up to 1.
So Alex's way is perfectly great. Like it's awesome. It's actually a bit tougher than you need to make it. But if it makes sense to Alex, more power to you, right? So 12% is what we find out is yellow because 6 over 50 is the same thing as 12%. So what Alex said is 12% of 10 would be 1.2. But can you have 0.2 of a marble? No, we got to round. Well, I don't know if you want to play with broken glass, but I don't really want to play with broken glass.
Can I use the restroom?
Yes. Well, I don't know. Can you?
Yes.
So green ends up being about 4, right? Yeah.
I did it differently.
Did you get the same answer?
Yeah. So there are
Got to
10,
Florida.
there are 10 marbles, right?
Yeah.
And so 5 plus 5 equals 10, right?
Yeah.
And
So you kind of proportionally reasoned, this will have the least, is what you're saying. So Addie, thinking about it differently, right, said, well, yellow's going to get the least. Keep going.
So yellow had 1, 9 had 2, orange had 3, and 19 had 4.
Yeah, if we just kind of divvy them up to match kind of the reasoning of the least amount of yellow, the next least purple. Yeah, I love it. Perfect,
They all
Daddy.
add up to 10.
Yep, and if it works, it works. All right, on the back. Probability of an even number when rolling your number cube. What's your number cube? I don't know if I got this out yesterday or not. You did. Because I'm still moving into this classroom. But number cube, right? Die, a dice. But 1, not 2. So please don't look at your probability cheat sheet. That's for 2 dice. This is just 1. Jana. Yeah, I mean, they're up there, so sure, you can say it. Do you want to say the answer for 72 before I reveal that one?
I got 7.75 times 16.2, which is 125.25.
I think we actually need to divide. So if we want to make 125 total, and we divide by what we make each week. Yeah, so this is correct. That's not the wrong answer. That is just the amount of money that we want to end up with. You probably either guessed and checked or did the division and then filled it in there. This is right. You have nothing to change. Okay, you just said it in a weird manner that I wanted to come check on it. Run it back now. What you haven't done is it looks like you're gonna have to spend some time on this because you can't copy all this down right now, Raphael, because I already moved on.
I wrote down the wrong thing.
So then down here, Margot, if we set up proportions, what is a foot and a half? Guys, those of you that are copying, we have a mini mastery tomorrow. I'm real concerned you're not going to know how to do this stuff on your own. I'm like, I know you're copying. We'll deal with that here in like a week or two of how do we get you to do your homework on time. If you don't know how to do this on your own, I'm real concerned. And we'll address it. Like we'll get progressings on things. But we set up 18 inches is a foot and a half, or you could set up 12 inches is 1 foot. Or what you don't have to use this. That's just kind of a reminder of there's 18 inches in a foot and a half. You don't have to use that though. If I use that, I can get to 36. From 36, I can get to 72. From 72, I can get to 144. What we do on top, we got to do on bottom. Questions? Okay. So division and multiplication are the same, right? So the same. I agree, sort of, right? Like quotations the same. So yeah, totally fine is what I mean. And breaking up your number lines based off the gap they showed you and the amount of gaps it took. We can figure out the scale and go from there. If it's done, you may turn it in, even though it's not due till tomorrow. Now we extended it, we gave you a little bit extra time. Guys, some of this is still a little bit of review that I'm not super concerned if we haven't gotten our homework done on time, but it's going to become more concerning. It's going to become a bigger concern. You are probably going to want a Chromebook. You don't have to have one for your group, but you're probably going to want one. So like 1 per team. 1 per team. I've lost my tab. If you choose to get out a Chromebook, we're going to go to the ebook 1.2.3. Either way, you need out your 1, 2, 3 notes. So your 1, 2, 3 like practice page that has the notes on it, you need that out. This is in your math notes. If you need a reminder of how to solve that final problem, that's making my brain like you drumming on the desk, like tapping. So it just distracts me. My ADD does not do well with all of that.
Oh, my husband has ADD.
What, squirrel? Yeah, this is why if you guys are making random noises and stuff like that, like it just messes with me, guys. I can't. I don't think I really have I was never diagnosed with it, but I don't know. Some people say I'm hyperactive, but I just don't. It's me. All right, so 75's on your paper. Check it out. Anyone want to read? It's on your paper, so you don't even have to look up here. Nobody wanting to read this morning?
I'll do it, I guess.
Alex?
It's 75, right?
Yep, you have been.
You have been handed a bag which contains 1 yellow, 2 red, 4 green, 5 blue blocks.
Do we think those numbers are important?
Yes.
Grab a highlighter and highlight them. You can grab 4 highlighters and highlight them in 4 colors if you want. If you go into the ebook and would like to kind of play with this, and you can do it later too, it's the 75E tool right here. We can also just do it as a class, right? If we click on the bag and pull something out. With your team, I want you guys to chat with each other and determine the probability, for each color they ask you there. By they, well, on my worksheet, I gave you a bit better space, right?
If you're a math teacher, why do you have pens on your desk?
Why do I have what?
Pens on your desk.
What?
Aren't you supposed to do math in pencil?
Oh, but grading. So we're right here, right, guys? So this is where we're going to start to, on your practice sheets that you turn in, expect that there is classwork also on that page. So when we're writing out these probabilities, we should be writing like P of, right? And then in parentheses, the thing you're finding. Chat with your team on the probability of each of these. So you don't really need that up right yet. Let's go ahead and do the paper. First, 1, 2, 3. So I'm going to move this out. Just on this right here. Now, what these are going to do is highlight the important
Where'd you get
numbers.
these and how much?
You grab a highlight. Highlight the numbers.
Asia? What's this card from?
Oh, we know about that.
If you make a mistake with the highlighter, you will break it.
What?
No, wait.
Yeah.
No.
Yeah, you better
Can I test it out?
Just, yeah, you can test it.
But
But like,
like,
only,
let's get in the
don't use it that
habit
much,
of,
because then it like fades it.
what we're talking about.
Just like do one line.
But that's a really good question. I'm not going to answer it right now, but that's a really good question. Hey guys, we need to be in the habit. We need to get in the habit of writing these out correctly so we know what we're actually talking about. So what I should see first is P parentheses red. And then that fraction. You just want another one? Were you here yesterday? So we didn't use this yesterday, so you could have forgotten to pick it up. Like that's maybe what happened. This doesn't belong in this binder, so we're gonna put that where it belongs here in a minute. But I'm gonna show you real quick. So chapter gave about the different probabilities. Yes.
Yeah, I asked that too.
That's a good question. I'm not gonna answer it, but it's a good question.
It's on purpose.
It's on purpose. I didn't say purpose. So to figure out probabilities, we're going to need to know how many we have. What do we normally do first in probability problems? find the total, right? This is a sign. Come back. You're not going to be allowed to. So this is really high priority. Where can you put that in your weight binder so you can do that too? Okay. Go ahead and put it right there.
Wait. Oh yeah,
This is
it
the
says
second
orange instead
copy
of yellow.
this.
Yeah, why not?
Okay. As long
little
as she says she did it already. All right, now where's that? Science?
Wait, Mr. Hudson.
Wait.
There's an
Error, I think.
An error?
There's no yellow. It says orange instead.
That's not an error.
It's not?
I know you probably want candy, but that's not a mistake.
No, it says yellow and there's only orange.
I know.
Oh, that's weird.
low probability of getting
Oh,
yellow.
Oh, he did it on purpose.
Okay, so I figured it out. I did candy.
Go ahead and look at 76, because I think you've all had long enough on set. Sorry, am I too excited, Margot?
Oh no, I like it.
Really loud.
Go ahead and look at 76. I can hear Mrs. Pettigrew right now. It's because we're excited.
No, but you were so loud.
Sorry, guys. I realize mine doesn't look like yours, and it messes with some of you guys when mine doesn't look like yours. So I'm really quickly going to make mine look like yours.
How much times did you say mine was like yours?
Enough. Is it an error, they ask?
It looks like one.
What's the wait, but there's no probability of getting orange?
You tell
There's
me.
no probability of getting orange.
Nor yellow.
Yeah. Taking a look at red.
You're hurting my brain. Please help me, Mr. Hudson.
That's a good thing.
You said put your pain on me.
And then look at 77. I want us to talk about all three of these problems all together. You should be talking with your partners. I'm waiting on purpose.
Oh.
This is wait time.
You guys didn't know that?
It's teacher wait time.
You're waiting on porpoise.
Because porpoise is slow. Sorry, waiting. Oh yeah, Emily Riga bought me a joke book.
Oh no.
Oh no.
What?
No.
What is
Actually,
a
I think math is really
fatigued?
fun personally.
What is a fatigued pea called?
P yellow.
Sleepy.
That's so bad.
All right, don't worry. I get my laugh no matter what.
Was that a laugh button?
Yeah, it's the laugh button.
I have a button like that, but it says no.
Get it? Because it's sleepy, because it's tired. All right, the probability of red. We haven't used any cards today. June is not here. Margo, what do you think the probability of red is? How'd you
I
find
don't
it?
know. She did it wrong, and then she didn't wait for me.
Wow, why are you blaming Lily?
Because she didn't wait for me.
So what you mean is pass.
Yes.
Okay. Christian, what do you think probability of red? One, I don't know what you mean by one. Because didn't we say that a probability of 1 means that something is 100% certain? So be careful. A probability of 1 means it's gonna happen. Lindy, do you have probability of red? It doesn't need to go to 1%. Fractions are actually kind of easier. How'd you get 12? Guys, step 1 is find your total. If you didn't do that, write down that your total is 12. Then Lindy said, I put my 2 red over the 12 total. And what could that reduce to? Anybody? 1 over 6. Because if we cut both of those in half.
Did I use the same process I used on 1, 2, 2?
I don't mean, what do you mean same process?
Like how I turned it into like percentages.
So you shouldn't do that actually because fractions are a better way to talk about probability. We a lot of times will then turn it into a percentage, like when we're talking about the weather report or like lottery. But fractions are better because a lot of times the fraction's more accurate.
Because this is
It's
really
actually more accurate. Look, I'm using cards. You're just making me feel bad by like not calling on you, but I'm using cards. Lily, do you got probability of green for us?
I'm figuring that out now. Come back.
Do you want to like figure it out live?
It's 1/4.
Ooh, back it up. What is it first? What would we write unreduced? 4 over 12. Guys, you need this down first because Lily fell in the trap door. Don't worry, we'll pull you back out. What can 4 and 12 both divide by?
2, 6.
Okay, well, I'll do that first. 2 over 6.
1/3.
1 over, oh, it's 1/3. You said 1/4. I don't know if you just said it wrong, but when we reduce it out, it comes to 1/3, not 1/4. Does that make sense? Yeah, I think you just said it wrong. Are we okay, gents? Are we getting this copied down? Because if this isn't on your paper, your practice work will end up being a check minus. Make sure you've got blue and orange done. I'm taking a lap to see who's lying to me and who's not actually writing this down with us.
I know orange. It's just 0. 0. Like there's no orange.
We keep up with one writing on the board.
Yeah.
You can't vote. You can only do the thing that's most important. Probability of blue, Alex.
Oh, 5 over 12.
So I'm going to write it down here because I'm running out of room. P of blue is 5 over 12.
And
So, Alex, grab that calculator real quick.
okay.
Calculus later.
Well, there's one in the bin, too. You don't even have to get out yours. There's one in the little bin.
Too late.
Do 5 divided by 12.
Stand at error.
Syntax means you type something wrong. So hit clear, clear. So do 5 divided by 12.
Oh, so we just divide it?
So hold up. Hey, I need your attention right here. Raphael, you with me?
Yeah.
5 divided by 12. What'd you get?
0.41, 461, or
0.
416. 6666667.
This is why we often just stick with the fraction. So if we try to write this as a percent, and we say 41.6 forever, it's still not as accurate.
So would that make it just like 0.4167? No, because that can't be.
Don't convert unless you have to. 5/12 is better. 5 over 12 is better than the decimal, better than the percent. The fraction's better. All right, I'll take a volunteer for probability of orange since so many of you were like mad at me and thought this was a mistake.
Oh.
Jana,
Thank you.
you're welcome. Thank
Thank
you.
I got 0 over 12.
How'd you get that?
Because there is no orange, so then when it would be 0 because there isn't. Why didn't you do P yellow?
Probability of 0 means it can't happen. You are welcome to start adding things on my dry erase boards during like AO and extensions and whatever. So here's an example I have for probability of 0. The probability of me flapping my arms and flying home, that cannot happen. Right? I've tried, right? Like,
If you believe in yourself, you can.
can't happen. I've tried. Can't
You
will it.
believe anything is possible if you just believe.
Ivan. You're not Ivan. Or are you just stretching again?
Yeah.
Man, you are messing with, I think you know what you're doing. You're just messing with me. Addie?
Actually, in science, you go to the lab, like volunteer yourself in the lab for science.
Okay, I will add today to the end of that sentence then.
You believe in yourself, anything is possible.
Have we talked about 76, 77?
Nope.
No.
Okay, 2-3 minutes. Talk about 76, 77 with your partner.
If you
believe you're
flying,
flying,
you
you're
will
flying.
select one block. And 12 times replacing the block between each selection of these. Of those times, we'd expect to have selected a blue block. I mean, there's a high chance.
We need to turn that to a percentage.
No, you don't. You are so stuck on wanting to make everything percent.
No.
Let
I
go
like
of it,
fractions.
Alex.
I wrote E.
What is this question asking?
Once you got back to something,
What's the probability of getting a blue?
No, it's not. How
I
many?
don't understand.
Not percent. We're trying to make an estimate of how many times.
Oh,
Mr. Hudson.
Yes, sir.
Just so you know, if Alex drops on there's something to learn from it.
There's our 5-minute alarm, so I gotta start wrapping things up. So, check it. This was time 1. Hey, hi, math. So that was time 1, right? All we need to keep track of is blues. In 76, we're asked how many times do we think blue would come up? And we just made a probability of 5 out of 12. Anyone want to tell me what your prediction for how many times blue would come up? Gabe? What was that? Well, just say it again, please. 5 out of 12.
I called it.
That's... Calm down. You're about to flip the table. That's what probability... Guys, that's what probability is telling us. Is if we do this a total of 12, we expect 5 of them to be blue. So let's try this. That was 1. Ooh, there's our first blue. Select 3. Selection 4. Selection. Second blue. Selection 6. Selection 7. Selection. Ooh, third blue. Selection 9. 10. 11. So, how many blues did we get? 4. Did that match what we expected? No, but is it close? Yeah. So, talk about what if we did it 24 times? What if we did it 24 times? Right? So go ahead and write, we would expect 5 times if we did it 12.
Even if you
But then you could write, we actually got 4.
But what if we turn it into a percent?
You don't need to.
Wait, would it be 10? Like, if you multiply,
So, Alex, before you start doing extra work that you don't need to do, let's do the work we're supposed to do.
Please. Okay.
All right, probability of blue. We said is 5 over 12. But what about, that's not the cards.
No, please.
Okay, Misk.
Yeah. So
would it be 10 over
Hey,
24?
Jana, you're being a little rude right now. Misk?
Would it be 10 over 24?
Yeah, if we turn it into 24 total, we'd have 10. Because we double. Questions? Is it actually a hand?
Yeah.
Ivan?
Would you multiply it by 2?
Yeah.
By every?
So if you want to show your work, what happens on top needs to be the same as what happens on bottom. Yeah.
Every single marble?
For if it was 24. So for 24, like our expectation for green would probably be 8 out of 24, right? If we double that for if we do it 24 times. If we turn this to a 24, what would this turn into? A 4. Yeah, exactly. So then 77, I now have you and a partner group put your bags together. Does that change your chance of getting blue or yellow or green? Anybody want to talk about what you think?
So wait.
I would say no because if as long as you have the same amount of each color in each bag, it would just double the top and the bottom.
So we put our bags together. Now instead of having 5 blue out of 12, we have 10 blue out of 24. Are those equal?
Yeah.
Yeah. So your probability would not change because if we double everything, these are equal. So if we double nothing changes actually. Nothing actually changes as long as we double everything. Alex?
Wait, so I tripled everything because there's 3 people at our table. So how would that not change?
So if we triple everything, it'd be 15 over 36. And if you do these divisions like you keep wanting to do, they're all the same percentage. All right, that's all the time I got.
Yes.
Flip your papers in. Flip your papers in. Flip your papers in.
I heard it.
Tomorrow we will have our mini mastery and a math binder check.
Oh.
It's all right. If it's goofed up, we'll fix it. Right? If it's goofed up, we'll fix it.
I need to get new.
If it's goofed up, we'll fix it.
I need to get new sticky notes. Mine are crumpled up.
And actually, we might stick the sticky notes up out the top this time.